Greetings of the day, students. We are studying about the computer graphics, and the code of this subject is KCS053, and we are having unit number 5, lecture number 2. So lecture number 3, I'm sorry. So we have studied in lecture number 2 that what is all about this Z buffer and what is all about this A buffer, scan lines. So now we will have this small introduction of this Z buffer that in the previous section we studied about the Z buffer, that it is having two kinds of buffers. Frame buffer, and then it is depth. So frame buffer and the depth buffer is totally different from each other. The Z coordinates are usually normalized to the range 0, 1. Okay, and the calculating depth value efficiently is having the definition like we know the depth values at the vertex. How can we calculate the depth at any other point on the surface of the polygon? Use the polygon surface equation. We had already studied about the equation, like it is equal to Z is equal to minus AX minus BY minus C upon D. So this D is having the coordinate function, and C is again the equation parameter to this Z factor, because the original equation is AX plus BY plus CZ is equal to D. So eventually we need to find out this Z vector. So this Z vector will extract from this position, like how we will omit minus X, minus BY, minus C, and so on. So it's actually plus D is equal to 0. So we will put aside on this right hand side D minus AX minus BY, and then we will find out the depth value. So for any scan lines adjacent horizontal X positions or vertical Y position differ by 1 unit, the depth value of the next position can be seen like it is having X plus 1 comma Y. So here we are having the particular grid and the particular range, and we had already seen that how different frames are concurrently working with each other. So this is having S1, S2, S3 frames, and it is going to reflect anyhow that this one, and the particular area. So the projection of these frames will be in the X direction and in the Y direction. How it is going to represent in the another third dimension, like it is the Z axis and so on. So it will have the particular value of this Z direction that the display can have the X comma Y, because all these frames are going to impact on this scale X, Y, and so on. So what are the depth buffer? It is used to store depth values for XY position. So this XY position of this plane, like here if we are having this XY position, then it is going to impact the entire scenario. So as surfaces are processed and this 0 depth less than 1. So the frame buffer is used to store the intensity value of color value at each position. So this step 1 and step 2 set the buffer value depth buffer xy is equal to 0. Depth buffer x comma y is equal to 0, and the frame buffer x comma y is equal to having the background. So the process each polygon for each projected pixels xy position of a polygon, calculate the new one. So how this planar equation, so we have planar equation ax plus by plus d is equal to 0, and this planar equation can be obtained using depth values for a surface position. Xy are calculated from the plane equation for each surface. So then we studied about the advantage and the disadvantage of this algorithm and how it is going to impact the entire projection. And the output will be totally different, and it can have the particular value also. Now we can have the advantage and the disadvantages of this function. So it is easy to implement this depth buffer method. It is easy to implement because the synonyms of this jet buffer is depth, buffer method. So it reduces the speed problem if implemented in hardware. It processes one object at a time. So what is the disadvantage here? It requires large memory because it requires large memory. These are the points we need to overcome. So it is time consuming process. It is time consuming process. So jet buffer algorithm and the different algorithm can have the different aspects. So given set of polygon in image space, that the jet buffer is equal to Z minimum, where Z minimum is value to display polygon decide color, intensity and depth. So by this way, we can remove hidden lines and display those polygons which are closer to I. So x strip y is the dimension which can space required to maintain Z buffer, and x strip y times will be scanned. So expansion in terms of time and space, as space is very large, we can have the different sections. So we had already studied about this section, that how this section is going to implement in either way, like it is having S1, it is having S2, and how it is going to project in different ways, like this is S1, this is X, and this is Y, and so on. So then we studied about the scan lines, and then we studied about the different questions those are asked in the question paper, that we can have the particular values like question number 1, those are expected from this section. Question number 1 is, what is object space? What is object space? Question number 2, list the advantages. List the advantages of hidden surface. Elimination. Question number 3, explain image space. Image space methods for 3D objects. So explain visible surface detection. Explain visible surface detection. Question number 5, differentiate between hidden surface and visible surface. So this can be done in different shapes, like how we are knowing about the particular section, knowing about the topic. So these questions will elaborate the minute things, and it will goes to the deeper part, that how we are going to implement this section. So next, now we are moving towards a buffer method. This method is also used for the back face detection and the illumination model. So a buffer method, what is the a buffer method? So it expands on the depth buffer method to allow transparency. Method the key data structure in the A buffer is the accumulation buffer, is the accumulation buffer. Then we can have the particular respective linked list value, those are defined. So here we are having two more important things, like one is depth field, second is intensity field, differentiating with each other, how the illustration part is done on the both side, like how this depth less than 0 and how this surface, because it stores it stores a positive or negative real numbers. It stores surface intensity information or a pointer value or a pointer value. So if depth is greater than equal to 0, then we can have the number of stored at that position is the depth of a single surface overlapping the corresponding pixel area. The intensity field then stores the RGB components of the surface color at that point and the percent of pixel coverage. If depth is less than 0, it indicates multiple surface contributions to the pixel intensity. The intensity field then stores a pointer to a linked list of surface data. The surface buffer is the A buffer, includes so many things. Like how many things it is include, we are going to discuss here. Let me remove all these parts because it requires so many things that we are going to focus in order to show the hidden surface or the hidden shadow. So what are the things that is going to include in the surface buffer? So the surface buffer includes RGB intensity 1, RGB intensity component, opacity parameter, number 3, depth, number 4, percent of area coverage, percent of area coverage, number 5, surface identifier. So the algorithm proceeds just like the depth buffer algorithm, and the depth and opacity values are used to determine the final color of a pixel. So we had already studied about the particular actions. Those are defined in either way, like how it is going to A, B, C, D, E, F, G, H. So this here we are having two surfaces, like this is surface 1, this is surface 2, and these scan lines are going to traverse in either way. Like suppose we are going to impact in this section, impact in this section, impact line, then the scan lines. So these are called, what these are called? These are called the scan lines. This is scan line 1. Here we are having scan line number 2. This is scan line number 3. Here we are having scan line number 4, and so on. So this is the part of scan line method which is also used in the A buffer, and it is an image space. It is an image space method to identify visible surface. So this method has a depth information. This method has a depth information for only single surface. Then we will focus on the particular edge lines, how it is going to maintain these two tables, like number 1, edge table, how this is going to maintain this vertex table, and so on. To facilitate the search for surfaces, to facilitate the search or search for surfaces crossing a given scan line. So pixel position across each line are processed from left to right. So this is left to right orientation, and how it is going to implement in this section. So at the left intersection with the surface flag is turned on, and at the right the flag is turned off. So here we are having the turn on significant tool, and here we are having turn off signal orientation. So you only need to perform depth calculation when multiple surfaces have their flags turned on at a certain scan line position. So what is the another step? This active list for scan line 1 contains information from the edge table for as AB. So here we are having this line AB, and it is going to impact like BC, EH, FG. For positions along this line between edges AB and BC, only the flag for surface S1 is on. So therefore, no depth calculations are necessary. No depth calculations is necessary. And intensity information for surface S1 is entered from the polygon. Similarly, between edges EH and FG, only the flag for surface S2 is on, because it lies on the left hand side and the S2 surface is lying on the right hand side. So no other positions along scan line 1 intersect surfaces, so the intensity values is the other area intensity. So for scan line 2 and 3, here we are having 2 and 3, we are going to focus the active edge list contains edges AD, EH and BC and FG. So those are lines, this is AD and then EH, here is EH is here. Then we are having BC and FG. So this BC and FG. Along scan line 2 from edge AD to edge EH, only the flag for surface S1 is on. So depth calculations must be made using the plane coefficients for two surfaces. So for this example, the depth of surface S1. So let us have the particular value, like how these operations and these steps are going to impact anyhow, and how it will be eventual effect of the surface. Okay. So for scan lines 2, for scan lines 2 and 3, the active list contains AD, EH, BC, FG. So along scan lines 2 from SAD to EH to S EH, only the flag for surface S1 is on. Depth calculation must be made using the plane coefficients. So the depth calculations is made using the plane coefficient. For the two surfaces. Then for this example, the depth of surface S1, depth S1 is assumed to be less than S2. So intensity of surface S1